Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is metallurgy, extraction of iron, copper and aluminium. Metallurgy is the branch of science that deals with the extraction of metals from their ores and their refining for use. The extraction of metals like iron, copper, and aluminum is a crucial part of metallurgy and involves multiple processes, each designed to obtain the pure metal in an economically viable and efficient manner. These metals are widely used in industries, construction, electrical applications, and transportation, making their extraction highly significant. Iron is one of the most commonly used metals and is extracted from its ore, hematite. The extraction process mainly takes place in a blast furnace, a large, vertical structure where iron ore is reduced using coke as a reducing agent. The process starts with the crushing and concentration of iron ore to remove impurities. The concentrated ore is then mixed with limestone and coke before being fed into the blast furnace. Inside the furnace, coke burns in the presence of hot air, producing carbon dioxide. This carbon dioxide reacts with excess coke to form carbon monoxide, which acts as the main reducing agent. The iron ore undergoes reduction, producing molten iron. At the same time, limestone decomposes to form calcium oxide, which combines with impurities to form slag. The molten iron is collected at the bottom and then used for making steel or cast iron. The slag is removed separately and has applications in cement and road construction. Copper, another essential metal, is extracted from sulfide ores like chalcopyrite. The extraction involves several steps, starting with the concentration of the ore using froth flotation, which removes unwanted earthy materials. The concentrated ore is then subjected to roasting, where it is heated in the presence of oxygen. This converts sulfide ores into oxides and releases sulfur dioxide gas. The resulting copper oxide is reduced using coke, resulting in impure copper known as blister copper due to its blistered appearance caused by trapped sulfur dioxide. The refining of blister copper is done through electrolysis, where impure copper is used as the anode and a pure copper sheet is used as the cathode. The electrolyte is an acidic copper sulfate solution. When electric current is passed, pure copper gets deposited on the cathode, while impurities settle as anode mud. This process ensures high purity copper, which is widely used in electrical wiring and electronics. Aluminum extraction is quite different due to the nature of its ore, bauxite, which contains aluminum oxide mixed with impurities like iron oxide and silica. The extraction process begins with the Bayer process, where crushed bauxite is treated with concentrated sodium hydroxide solution at high temperature and pressure. This dissolves aluminum oxide, leaving behind the impurities as red mud. The solution is then cooled, and aluminum hydroxide precipitates out. Upon heating, it forms pure aluminum oxide or alumina. Since aluminum cannot be extracted using carbon reduction, it undergoes electrolytic reduction in the Holherold process. In this process, alumina is dissolved in molten cryolite to lower its melting point and then electrolyzed using carbon electrodes. Aluminum is deposited at the cathode, while oxygen is released at the anode, which reacts with carbon electrodes to form carbon dioxide. The extracted molten aluminum is then cast into ingots and used in transportation, aerospace, and construction industries. Initially, the ore undergoes froth flotation, where crushed ore is mixed with water and chemicals to separate impurities. The concentrated ore is then roasted in the presence of oxygen, converting iron sulfide to iron oxide and copper sulfide to copper oxide. In the next stage, the roasted ore is subjected to smelting in a reverberate furnace. The iron oxide combines with silica to form slag, which is removed. The remaining copper sulfide undergoes further reduction, forming impure copper, known as blister copper due to the blistered appearance caused by sulfur dioxide bubbles. Blister copper is purified by electrolytic refining, where impure copper is used as the anode and pure copper is deposited at the cathode. During this process, impurities like gold and silver settle at the bottom as anode mud, which can be collected and further processed. Now, let's talk about aluminium, a lightweight metal widely used in aircraft, packaging, and construction. Aluminium is extracted from bauxite, AlO.2HO, through the Hall-Heroult process. The extraction begins with Bayer's process, where bauxite is treated with concentrated sodium hydroxide at high temperature and pressure. This converts bauxite into soluble sodium aluminate, leaving impurities behind as red mud. The sodium aluminate is then cooled and seeded with aluminium hydroxide crystals to precipitate out pure aluminium hydroxide. The precipitate is heated strongly in a rotary kiln to obtain anhydrous alumina, AlO. This alumina is then subjected to the Hall-Heroult process, where it is dissolved in molten cryolite, NaLF, to lower the melting point. The molten mixture is electrolyzed in a cell with carbon electrodes. At the cathode, aluminium ions gain electrons and form molten aluminium, which settles at the bottom. At the anode, oxygen reacts with carbon to form carbon dioxide, which escapes as gas. The molten aluminium is periodically tapped out and cast into desired shapes. The metallurgy of iron, copper, and aluminum highlights the scientific principles behind metal extraction, including redox reactions, electrolysis, and thermodynamic considerations. These metals form the backbone of modern industry and infrastructure, making their extraction and refining crucial for technological advancements. Thank you. We hope this video has helped you gain a clearer understanding of hydrogen and its compounds, especially the fascinating role of heavy water and isotopes. If you found this video helpful, make sure to like, share, and subscribe to AskPrep for more in-depth chemistry lessons. Keep studying, stay curious, and good luck with your exams.